analysis, what is a salt? Salt is formed when along with water when an acid and base reacts. Examples are NaCl, NH4Cl, Ki, CH3CO, Na, NH4NO3, NH4Cl, etc. So, if we take an example of HCl and NaOH. HCl is our acid while NaOH is our base, and these two reacts to form NaCl plus water. So this is our salt. Alright. Now there are various categories of types of salt, and we define those categories based on the type of acid and type of base we are taking. Acids can be of two types: strong acid, weak acid. Similarly, base is also of two types: strong base, weak base. Alright. And the cationic part of salt is always provided by base, and anionic part is always provided by acid. So whenever we write down salt of strong acid and strong base, that means the anionic part is provided by your strong acid, while the cationic part is provided by your strong base. Now let's see the various types of salts. The very first type is salt of strong base and strong acid. The reason I have written in here strong base earlier is because this is providing cation and this is providing anion. So, salt of strong base and strong acid examples are NaCl. NaCl is formed by reaction of NaOH and HCl. Ki, similarly KOH reacts with Hi, KNO3. So KOH reacts with HNO3, RBBr, BaCl2, CaCl2. All these are examples of salts of strong acid and strong base. Now, ions that undergo hydrolysis. What happens that sometimes you have some salt in which ion forms. Let's try to understand this with an example. NH4Cl. Alright. So this NH4Cl in water get ionized and it will form NH4 positive plus Cl negative. Now this NH4 positive is H plus donor. H plus donor. And in our Bronsted-Lowry concept, we have understood that H plus donor is acid. Alright. So what will happen? This NH4 positive in water get undergo hydrolysis and it will provide a proton to the water molecule. Alright. So this will undergo hydrolysis, but if you see the example of Cl negative, this will not undergo hydrolysis. This is proton acceptor. Let's see how it will not undergo hydrolysis in aqueous solution. For example, if let's suppose it accepts the proton, what it will form? It will form HCl. HCl is a strong acid, and we know that in an aqueous solution HCl is only present in the form of its ions, that is H plus and Cl negative. Not a single molecule of HCl will be present in the aqueous solution. Therefore this reaction doesn't happen. That's why the Cl negative doesn't undergo hydrolysis. This will not happen. This reaction will not happen. only the NH4 positive or only the cationic part will undergo hydrolysis. Now what will happen when the hydrolysis occurs? Your Cl negative will be present in the form of Cl negative only, and your NH4 positive will break down into ammonia and it will donate a proton to the water molecule, and you will have proton in excess. Only H positive and OH negative defines the pH of a solution. So this NH4 positive is contributing to the concentration of H positive, and there is not much change in the concentration of OH negative. So the solution will be acidic. So this solution will be acidic. So try to understand this thing in case of strong base and strong acid. What will happen in case of strong base and strong acid? Both the ions will not undergo hydrolysis. Let's take an example of NaCl in water. What will happen? It will ionize and form Na positive and Cl negative. Now these two will not undergo hydrolysis. Let's say it undergo hydrolysis. What will be formed? NaOH plus H positive. Again, it's a strong base, so it cannot be present in the form of a molecule. It will be present in the form of its ions. So this reaction will not happen. Similarly, Cl negative we have already discussed. So these ions will not undergo hydrolysis. So no more H positive or OH negative is being formed. So the pH of solution will be nearly equal to 7, or you can say neutral. Now second example is of strong base and weak acid. So we'll take an example of CH3COONA. Again, in water it will dissociate into its ion CH3COO negative plus Na positive. This Na positive will not undergo hydrolysis. No hydrolysis. But this CH3COO negative will undergo hydrolysis, and what will happen in this case? In this case, CH3COO negative on reacting with a water molecule will form acetic acid and OH negative. Now this acetic acid is a weak acid, so it will not completely ionize. It will be in equilibrium with its ions, that is CH3COO negative plus H positive plus this acetic acid. All these three species will be simultaneously present in the solution. So it is contributing to the OH negative production. OH negative will be produced in the solution, and your solution will be basic. So the pH will be more than 7. So this is the case, and your solution here will be basic. Example of a weak base and strong acid we have already discussed, that is NH4Cl, and in that case your solution will be acidic. Alright, now salt of weak base and weak acid. In the case of salts of weak base and weak acid, both the ions will undergo hydrolysis. So let's take the example of CH3COO NH4 in water. It will dissociate into its ions. Now CH3COO negative on reaction with water forms CH3COOH plus OH negative. Similarly, NH4 positive on reaction with water gives ammonia plus H3O positive. Alright, and since both of these are weak, what will happen? This reaction will occur, and in both the cases you will get OH negative and H3O positive concentration. Now, how will you decide which one is dominating, whether your OH negative is dominating or your H3O positive is dominating? How will you decide whether your solution is acidic or basic? So to identify that, you have to look for the value Ka and Kb values of these reactions, and these will define whether your solution will be neutral, basic or acidic. So if you have, here I have written, if you have Kb less than Ka, then your solution will be acidic. But if you have Kb equal to Ka, that means your solution will be neutral. If you have Kb more than that of Ka, then your solution will be basic. Alright. Now there is one more thing I have written here, that is small highly charged cation. So taking example of small highly charged cation and halide from the strong acid, we will take AlCl3. In water, it will dissociate to form Al3 positive plus 3Cl negative. These Cl negatives will not undergo hydrolysis, so here no hydrolysis, but this Al3 positive being highly charged, it will form hydrated sphere with water molecules. Since oxygen atoms have two lone pairs present in it, so it forms the sphere in such a way that this charge gets neutralized. Now what happens? Another water molecule takes away one H positive from this. So let's say it's a water molecule. So what will happen? This oxygen will take away the proton, and it will easily provide it and form a species like this, where you have OH and this happens because it's a positively charged species and it will try to neutralize itself, so it will lose a proton here, and after losing the proton, this water molecule will become H3O positive, and since H3O positive contributes to the acidity of the solution, so your pH will be less than 7 in this case. So that's the case here. You have hydrated cation, and this type of chemistry happens, and protons increase in the solution, resulting in the acidity of the solution.